Data can be represented in various tables and graphs. But which tables or graphs should I choose? We select graphs or tables based on the types of variables and the number of variables. If we have one categorical variable, then we can use frequency distribution table, bar chart, pie chart, etc. Let's discuss one by one. Do you like to watch movies? Maybe yes. Then what is your choice? Drama, comedy, or thriller? Think about a categorical variable, movie genre. Assume it has 3 categories: drama, comedy, and thriller. Suppose you have asked a few movie lovers about their choice. Now you have to represent this data in tables or in graphs. How can you do that? Suppose you have surveyed 170 people. First, create a frequency distribution table. Suppose 45 people like drama, 70 like comedy, and 55 like thriller. These are frequencies or counts. Next, calculate relative frequencies. To calculate relative frequency, divide frequency by the total frequency. Multiply it by 100 to get it in percent. Frequencies and relative frequencies both can also be presented in a bar chart. In a bar chart, frequencies or relative frequencies are plotted against different categories. Bar length represents the frequency or relative frequency. All bars are separated because all categories are disjoint. Here, I have created a bar chart of relative frequencies. 26.5% like drama, 41.2% like comedy, and 32.4% like thriller. If you want, you can plot the counts instead of proportions. Let's represent the data in a pie chart. Remember, actual frequency or counts cannot be represented in a pie chart. Only the relative frequency can be plotted in a pie chart. We assume the area of the whole pie is 100% and every slice shares its area. The same story is graphically displayed. What about quantitative variable? If there is one quantitative variable, then we can use frequency distribution table, histogram, kernel density plot, box plot, etc. Suppose the age of 15 students is known. How can we represent the data in graphs or tables? Let's create a frequency distribution table. To create a frequency distribution table, first we create a few bins, or classes of the numeric variable age. I have taken 4 bins, 10 to 15, 15 to 20, 20 to 25, and 25 to 30. The bin, 10 to 15 means, age is 10 or more, but less than 15. Remember, bins must not be overlap. In step 2, count the frequency or the number of students for all bins. In step 3, calculate the proportions. Now, we plot the frequencies on a histogram. In a histogram, frequencies or relative frequencies are graphed against bins of the numeric variable. Each bar length represents the frequency or relative frequency. Bar width represents the class interval. There is no gap among bars because we are dealing with a numeric variable here. Here, you can see, age groups are on the x-axis, and frequencies are on the y-axis in the histogram. Each bar has an equal width of 5 years. The height of a bar is the frequency of a specific age group. Similarly, we create a histogram of the relative frequency of age. The graph shows that, if the total area of rectangles or bars is 1, then, the area of the bar of age group 10 to 15 is 0.667. In other words, we can say, there are 66.7% of students between the ages of 10 and 15. Using a histogram, the shape of the distribution and variability can be understood. However, this graph is not good to find outliers. Kernel density plot. Another way, numeric data can be represented using a kernel density plot. This plot uses a smooth continuous curve instead of multiple bins. The total area under the curve is 1, or 100%. Using this plot has the benefit of being unaffected by the number of bins, unlike a histogram. Similar to the histogram, the shape of the distribution and variability can also be clearly understood from a density plot, though outliers cannot be detected. Numeric data can also be represented on a box plot. The box plot shows the minimum, maximum, first quartile, second quartile or median, and third quartile. A useful graph to understand the skewness and dispersion or the variability of the data. Also, it helps to find outliers in the data. However, it does not show a clear picture of the data density. To get a clear picture of data distribution, we need to check the kernel density plot. Sometimes density plots are drawn above box plots to understand how the data is distributed exactly. A few software also adds mean on a box plot.